Hey everyone, welcome back. Okay, so today we're going over multiplying integers. One of the things that we mentioned in class was that multiplying integers is very different from adding and subtracting integers. And we find that a lot in all aspects of math. You've noticed in fractions that when you add and subtract fractions, you need a common denominator. But when you multiply and divide, you don't. Same idea with decimals. When you add and subtract decimals, we always line up the decimals so that we can get the tenths in the tenths column and the hundredths in the hundredths column. But when we're multiplying and dividing decimals, we don't have to worry about that. Same idea here. When we're adding and subtracting, when you look at the adding and subtracting rules, you're going to notice that they are different from the multiplying rules. So let's see if I can make a picture available for you though. When you think about multiplication, you should just be thinking about repeated addition. So when you had a problem like 4 times 3, what that means is that since you always start at 0, what it means is you want 4 groups of 3, or 4 steps of 3. And that's why you always end up at 12. If we wanted to do this with blocks, notice here's one group of 3, and here's 4 groups of 3. If you count them up, you guessed it, there's 12 blocks. Another example would just be 5 times 2. Notice, this is 5 groups of 2, or 5 steps of 2. And that's why you get to 10. Once again, if we look at the blocks, here we go. There's a group of 2, and here's 5 groups of 2. You guessed it, 10 blocks. Okay, so that was 3rd grade. Now, how did we tie this into what we're learning now in 7th? Well, one of the problems we've got now is 4 times negative 3. What does that mean? The exact same thing it meant back in 3rd grade. We want 4 steps of negative 3. The only deal is that negative 3 goes in the other direction. And you guessed it, guess where we end up? Negative 12. If we think about it in blocks, here are 3 red blocks, or negative 3. And here is 4 groups of negative 3. Count them up, you got it. 12. 12 what? 12 negative blocks. Once again, here we go. I'm sure you guys can guess what the answer is going to be. It's going to be negative 10, because it's 5 steps of negative 2. Or it's going to be 5 groups of 2 blocks, which is negative 10 blocks. Okay. Now we've handled what do I do if one number is positive and one number is negative. 4 steps of negative 3 got us to negative 12. 3 steps of negative 3 gets us to negative 9. 2 steps of negative 3 gets us to negative 6. And 1 step of negative 3 gets us to negative 3. Now if we don't take any steps at all, it doesn't matter what number we're multiplying by, the answer is always going to be 0 because we didn't take any steps away from 0. With this information, I hope you're noticing a pattern. Negative 12, negative 9, negative 6, negative 3, and 0. Because that's going to lead us to what our next problem is. Do you notice this pattern? 4, 3, 2, 1, 0, negative 1. So what do you think negative 1 times negative 3 would be? Well, if we follow this pattern, negative 12 plus 3 gets you negative 9, negative 9 plus 3 gets you negative 6, negative 6 plus 3 gets you negative 3, negative 3 plus 3 gets you 0, and 0 plus 3 would get you guessed it, positive 3. So, negative 1 times negative 3 equals positive 3. When a negative is times a negative, the answer is positive. Negative 2 times negative 3, you guessed it, positive 6. Negative 3 times negative 3, you guessed it, positive 9. All right, let's go over the rules. Please feel free to pause here because I'm going to go through this quickly. When you have the product of 2 integers with the exact same sign, the answer is positive. So in an example, negative 3 times negative 6, the answer would be positive 18. The product of 2 integers with different signs will always have a negative answer. That means that 3 times negative 6 would equal negative 18. It would also mean that if it was negative 3 times positive 6, the answer would still be negative 18. And of course, anything times 0 is just 0. One of the things that we talked to the kids about was the light switch rule. Ask them about that. It's hard to demonstrate here on the computer. The exact same thing as the triangle rule, just hard to demonstrate on the computer. So I'm going to ask the kids just simply to be able to tell me is the answer going to be positive or negative. In this situation, the answer would be negative because one number is negative and one number is positive, and that leads to a negative answer. Here, since they are both negative, that would lead us to a positive answer. And that's going to be the part that's not very intuitive for some students, so please make sure to work on it with them. Here we go, both positive. This goes back to 3rd grade. You know it's going to be a positive answer if we're back in 3rd grade. And again, 2 negatives makes a positive answer. So, just to review, the product of two integers with the same sign will always be positive. The product of two integers with different signs will always be negative. And I'll give you a chance to be able to try some. 5 times 6, they're both positive, so that means they're the same sign, and that means the answer is going to be positive 30. Here I have two negatives, which means they're both the same sign. Two negatives means the answer is going to be positive 16. Here I have one negative and one positive down here. 3 times negative 12. And so, since I only have one negative sign and one positive, they're different, so the answer is going to be negative. And lastly, here's one negative and one positive, so the answer is going to be negative 35. And that's it. That's all the rules that we have for this. Please make sure to go over it with your kids, and if you got any questions, please feel free to give me a call. Have a great night. Talk to you guys later.